All right, we are going to be going over the key here. Now, I'm not going to go over every specific problem, but just the problems that I anticipate you guys having trouble with. So once my phone connects, there we go. So I'm not really going to go over these questions up here because these are just entering it into the calculator. Just remember this one goes in front of the choose, this one goes after the choose. If you get this answer, you should be able to get this. Remember, don't plug in n into your calculator because this is a variable. This is saying in general, what would the answer always be? Not going to go over this one. I am going to go over this one though, because if we look at it, how many possible passwords are possible for a 6-digit iPhone password? So I know all of the digits are from 0 to 9, and that is 10 options here. And I can already predict a lot of people are going to say this is a 10 choose 6. Well, it really is not going to be 10 choose 6 because, I mean, think about it in general. If it was 10 choose 6, that'd only be 210 options for people to choose from. That's not a lot of options. But this is kind of like the lottery problem we did. We have to treat every single number as its own event. Okay, so if it is every single number is its own independent event, it's not 10 choose 6 anymore. It's going to be 10 choose 1. You have 10 total options and we're choosing one. And so remember, and means multiply. We have another option, 10 choose 1, and then and 10 choose 1, and 10 choose 1, and 10 choose 1, and 10 choose 1. So in total, all these are going to be 10. So 10 times 10 times 10, 10 times 10 times 10. That's going to be 10 to the 6th power. Whoops, 10 to the 6th power. And then you would just add on your zeros here. So we go 1, and then 6 zeros after that. So 1 million total options here. So that's a lot more safe for us to protect what's ever on our phone. So we have 1 million options. All right, let's deal with these. I anticipate these being a problem for us as well. Find the possible 5 card hands in a standard 52 card deck with the specific cards. So 5 face cards. That means you got kings, queens, or jacks. And I went ahead and go and listed them out over here. So kings, queens, or jack. If we are looking at this, there's 4 of each kind, right? So 4 kings, 4 queens, 4 jacks. So in total, we have we are looking at selecting 5 cards from our total amount, which is going to be a very specific amount, that 12 cards here. And now if I was going ahead and entering it into my calculator here, we get math, and then we get 12 choose 5, then enter it. That's a total of 792 options there. So doing that, and then let me just go back to my camera. Okay, now let's look at this one. 1 ace and 4 cards that are not aces. So if we're selecting 1 ace, that means we are choosing 1 card from how many different cards here? We got 52 cards. Or not 52 cards, sorry. I'm interpreting that wrong. We have 4 out of 52 cards, but we're only going to select 1. So 4 out of 52 cards means we have 4 options to choose from, or 1 option to choose from, 13 different suits. Sorry, 13 different types of cards. It's late right now. My head is kind of going all over the place. So and means multiply. Now we are going to select 4 cards. So we're choosing 4 cards. And all the rest that are not aces. So you got to interpret how many cards are not left if you eliminated all the aces. So you took away 4 cards from 52. So you have 48 options left. So I'm going to go ahead and type this in. I already know this is going to be 13 times something, because 13 choose 1 is always going to be 13. And then we type it into our calculator. So 48 choose 4. 194,580, and we're going to multiply that by 13. So in total, we got 2,529,540 options there. Okay, let's go back to it. All right, 4 kings and 1 other card. So if we are selecting 4 kings, that means we have 4 cards we are choosing with. And now you think to yourself, in total, how many kings are there? Well, I see 1, 2, 3, 4. And so we're going to multiply, and 1 other card. So we're selecting 1 card, and now what's our total? We don't have any kings left, so we have 52 minus 4, which is 48. So I know right away this is going to be 1, because we have 4 cards and we're choosing from 4, so that's going to be 1. And 48 choose 1 is just 48. So the total amount of outcomes here is just 48. Okay, let's look at D now. D is at most 1 queen. So we got 2 different scenarios here. We could get no queens, or we could get 1 queen. So looking at no queens, that means we had select 5 cards out of 48 different options. Because we are excluding all of these queens right here. So there you go. Or, so or means add, you could get 1 queen. So you can choose 1 queen from 4 different ones, and then you can select 4 other cards that are from the 48 different options. So let's take a look how we would enter that. So I'm going to go ahead and type in 48 choose 5. So math, 48 choose 5. So right away here we get 1,712,304. Then and, well, 4 choose 1 is just 4. We got to multiply that with 48 choose 4. So math, and we're going to do 48 choose 4. So 194,580. So let's multiply that by 4, see what we get. We get 778,320. We are going to add that with our previous answer, 1,712,304. And we would get 2,490,000. And that's going to be our answer for this one. Okay, so that's the front page. I anticipate that being the worst of your troubles. Let's kind of go on to the back page here. Calculate the probability of k successes for binomial experience consisting of n trials with probability of p of success on each trial. So if you ever see something like this, remember your formula. It's going to be A or N C K probability of k times 1 minus probability of n minus k. I believe on our paper we wrote this as r, rk. They're basically the same thing. Okay, so now we got to interpret this. So k is at least 3. So you got to interpret all the different scenarios here. It's not just going to be k equals 3. You got to include k is 0, k is 1, k is 2, and then k is 3. So let's do k is 0 first. So we got in total 7 options. We're choosing 0. Now our probability of success is 0.3. That's the 0 power, and the probability of failure would be the 1 minus 0.3, which is 0.7 to the 7th power. And now let's write the other option. 7, choose 1, 0.3 to the 1st power, then 0.7 to the 6th power. These exponents should always add up to your total. So 6 plus 1 equals 7, 7 plus 0 equals 7. We're good there. Then we got 7, choose 2, and then 0.3 to the 2nd power, and then 0.7 to the 5th power. And then lastly, 7, choose 3, 0.3 to the 3rd, 0.7 to the 4th. And now we just got to put all these into our calculators and add them up. For the sake of time, I'm not going to do that, but I will write the answer on the key for you. All right, let's go down to here. Are the following questions a binomial experiment? If you ever see this on there, so are they? You better write this on your paper. Bins. So remember what that stands for. Is it binary, independent, set number of trials, and then same probability? So let's kind of go through here. Consider the experiment where 3 marbles are drawn without replacement in a bag of 20 red, 40 blue marbles, and the number of red marbles drawn is recorded. Is this a binomial experiment? So we are looking at binary right here. It's red, and then you got not red. So that is success, that is failure. And then independent means that the previous outcome did not affect the outcome that we are drawing from now. So let's kind of go through this and just pretend for a second. We have a set of 20 marbles. So we have or set of 20 red, and then you got a 40 blue. So in total, right away, your probabilities, if you were to do this the first time, would be 20 out of 60, right? Because 20 plus 40 is 60, and you want to go out of your total. So let's say you didn't get it, though. You drew a blue marble, but then you didn't replace it. So the next time, your probability is going to be 20 out of 59, and then so on after that. It affected your probability. We could enter this, and the probability that this event is going to occur is going to be more likely than the previous event. So since it says without replacement, that is not an independent probability. So we would say, no, they are not replacing. And I would actually probably put an X there. I put check marks for one that we know are good. So if we don't satisfy one of these things, then we know we cannot do a binomial experiment. If we satisfy them all, like I'm going to tell you right now, this one you are, then you can do a binomial experiment. All right. Now you got to make a histogram. Consider the example again with the 4-digit four multiple choice questions of which you have no knowledge. Create a histogram of the binomial experiment. So a histogram, I know if we're doing this binomial experiment, on the left-hand side is going to be the probability of the event occurring. So probability. Now, I specifically want to look at the questions that I got right. So questions answered correctly. And we can have 4 or 5 options here. You could get 0 correct, 1, 2, 3, 4. And if we think of a traditional multiple choice question here, you got 4 options. You got A, B, and C, and D. So when I am seeing the probability of a binomial experiment of an outcome, we should be using this formula here. So I need to write that down here. If I'm looking for the total number that you can choose from, it's 4. We got 1, 2, 3, 4. Let's look at the chance it would be if I got 0 correct. So 4, choose 0. Now, what's the probability of success? Well, we only guess once on here, so we only get one bubble we get to fill in. We got 4 options, so 1 out of 4 is 25%. So you could just say 1 out of 4 if you wanted, and this would be 0. 1 minus 1 out of 4 is 3 out of 4, and this would be 4. And we would go ahead and enter that in our calculator. And I'll do this one at the end. So then the next one we're going to look at is 4, choose 1. We get 1 out of 4, 1. 3 out of 4, 3. Next up, 4, choose 2. So the probability of getting 2 correct here. 1 out of 4, 2. 3 out of 4, 2. Then next up, 4, choose 3. 1 out of 4. Then we're going to go 3. 3 out of 4, 1. Last up, we get 4, choose 4. 1 out of 4, that's going to be 4. 3 out of 4, that's going to be 0. So we can kind of just generally think about this. If there was 4 questions on a test, where would you expect, how many questions would you expect to get right or get correct? Well, your probability is 1 out of 4, so 1 out of 4. It's going to be the peak is going to be right here. And then you should see that getting 4 correct, probably going to be very unlikely. If you do that, enter the lottery because you got some pretty good luck. So let's actually calculate these. So math, we can do 4, choose 4. 4, choose 0. It's going to be 1. So I'm just going to actually go ahead and write these out because I already know. If you guys enter in my calculator, that's fine. So 1, 4, choose 1 is 4. 4, choose 2. This one would be 1. This one would be 4. Then 4, choose 2. It's going to be 6. Yeah, 6. And then we can enter the fractions into our calculator. 1 over 4 to the 0 power is just 1. 1 over 4 to the 1 or first power is going to be 1/4. 1 over 4 to the second power is going to be 1 over 16. And then here, 1 over 4 to the third power is going to be 1 over 64. 1 over 4 to the fourth power is going to be 1 over 256. And then I can kind of go back the other way. 3 out of 4 to the 0 power is just 1. And then 3 out of 4, or 3/4 to the first power is going to be 3 out of 4. 3/4 to the second power is going to be 9/16. And then 3/4 to the third power, it's going to be 27/64. And then 3/4 to the fourth power, it's going to be 81 to the over 256. 81 over 256. So I can already just multiply these straight across, and if you want to enter these in your calculator, you can. I would suggest multiplying the fractions and putting them to the exponents, and then multiplying with whatever you got for your combination. So here is just going to be 81 over 256, which I'll enter in my calculator. 81 divided by 256. It's going to be a 0.316% chance of happening. Then I'm going to do 4 times 27 for the next one. And then we are going to divide by 256. Next up, we got 6 times 9, which is 54, and then 54 divided by 256. And then we get 4 times 3 is 12, and then 12 divided by 256. .047. And then last one, we get 1 divided by 256. Which is very, very small. So 0.00, let's say 4. So going back here, if I was to enter these in, well, my tallest peak is going to be right here, that 0.421. So I'm going to just go ahead and say, here's 0.4, and then here's 0.5, and then just kind of go down the line. Okay, so 0 was at 0.316. So with these, I want to make them equal width because we don't want to represent our data. And then 1 was 421. And then we had 2 was 0.21. So more down here now. We can see a lot less likely to occur. And then 3 was about 5%, a little less than it. And then 4 was very, very unlikely to occur. That's why I said you should enter the lottery if you get all 4 of those correct. Okay, so we may or may not have talked about this. Symmetrical would mean right down the middle. So like a bell curve. So something you could literally fold on the other side. Now, I would say this graph is skewed to the right because we could honestly think of it like a shoe. And then here would be your feet over here. The bulk of your shoe, think of like a heel. Your highest point is going to be here in the heel because it's raised up. And this is where your feet would be. So whatever way your toes are going, that's the way you say it's skewed to the right, or whatever way it extends out. Now, if we had the peak over here and it continued on over there, then we would say that it extends out that way. And my phone just died, but it's actually a good point for me to stop because we were done there. So if you got any questions, let me know. I'm going to have the key up here at some point tonight. I would say around 6 or 7 is when I normally do it. And then you will have a sub this day. So make sure to have your note cards. I will let them know that you are able to use them. Okay. All right.